So, and it still has hagfish on it. Those are the elongate eel-like looking things. So this is evidence that will stick around for a very long time. We have no idea how many whale falls are in the Gulf. And we also don't know about dolphin falls. We have a lot of dolphins wash up, but we don't know how many sank. Another species of concern is the whale shark. They make their living by filtering water, often right at the surface, and they have a complex filter system. It's almost pavement-like, very porous pavement, and water passes through that. It strains the plankton from the water, and then the water passes over their gills. So if they clog this filtration system with oil, not only can they no longer eat, they can't breathe. Now, a lot of whale sharks were tagged with satellite tags before the spill by chance, and they were found to occupy the area. These are the area of the spill. These are sightings, not necessarily from pop-up tags, but just sightings of whale shark distributions. And this is from Eric Hoffmeyer with the Gulf Coast Research Lab. And you can see that whale sharks are extremely common around the area of the spill. These data were collected prior to the spill, and they were observed in the spill afterwards. Observed interspersed among different floating slicks of emulsified oil or mousse. This isn't an actual photo of them from the spill, but I spoke with Eric Hoffmeyer last week about this, and a number of them were observed actually in the spill. So we really don't know what happened with them because they generally sink when they die. So this is something known as cryptic mortality, when you have things dying and you have no idea it's going on because it's hidden from view. There are other types of mortality that are very conspicuous, like this fish killed. It looks like pavement, but it's made of individual fish floating on the surface of this waterway in Louisiana. This is an annual event. It happens every summer. Most of the time it's not related to oil, and in this case it didn't look like it was related to oil. It was a coincidence. So not everything bad that happens is caused by the oil spill. This was probably caused by low dissolved oxygen, and the hot temperatures during the summer just aggravate the problem. The species that is very much the topic of concern is the Atlantic bluefin tuna. Even without the spill, some people were predicting that it may go extinct within the next decade or so. They spawn in the area of the Gulf where the spill occurred. The figure to the upper right is a map of the Gulf of Mexico, and the warm red and yellow colors are sightings of these large tunas. These tunas are really massive animals. They only congregate in two areas to spawn, the Mediterranean and the Gulf of Mexico. And they tend to aggregate in the northern Gulf of Mexico. They're a species that lives a long time, and whenever you have these long-lived species, they tend to have very age-structured populations. In other words, they have a lot of different age classes or year classes that make up the spawning stock, and so their dynamics can become very complicated. And that means you may not really detect a population level effect for years. If you start to interfere with year classes now with the oil spill, it may take a number of years for it to become evident at the population level. As an example of tuna's movement in the Gulf, this was a satellite tagged tuna that sent its location to a satellite every time it came near the surface. It was tagged up in Nova Scotia in 2008, so this is before the spill, just showing the natural tendency in the distribution. The tuna entered the Gulf of Mexico from near Cuba, the southward part of that track, and then spent a great deal of time in what would later become the oil spill area, and then eventually moved out. So these fish really do have, and not just these tuna, but a lot of species of fish and marine mammal have a really close association with this particular part of the Gulf of Mexico. The combination of the river discharge and the topography and the physical oceanography make this an attractive area for feeding and spawning. So as Bob mentioned, we really don't understand a lot of the effects of oil and dispersant on the eggs and larvae. But during the Exxon Valdez spill in 1989, egg mortality, fish egg mortality appeared to be higher right after the spill. A lot of fish just broadcast their eggs into the water, so they're floating, drifting, and they're subject to, there's no parental care in the vast, more than 97% of the species. So the eggs are just at the mercy of the currents and whatever the water chemistry happens to be. Also in the Exxon Valdez spill, there were larval deformities. So the larvae are also planktonic and just drift around. And it was suspected that they had depressed immune systems, but never proved. Bluefin tuna larvae look like this right after they hatch. And there are some sublethal effects that aren't necessarily detected or evident from laboratory studies. In nature, if an animal shows any sign of distress, it's preyed upon in general. Predatory fish aren't very polite to their prey when it starts to become impaired. So a very sublethal, very subtle change in behavior can have a sublethal effect. And that type of dynamic or response isn't evident in the laboratory tests that people use to determine toxicity. The lab tests are based on actually causing death. 50% death after 96 hours is a threshold used to determine toxicity. In reality, if those, and that includes an animal or like a larval fish that has fallen to the bottom of the container but is still moving its gills, it's counted as being alive. So these lab tests really have no real translation into what's going on in the natural world. So you may hear that the toxicity is below a threshold level, but in reality, minor impairments to the behavior of fish or crustaceans or even fairly large animals can result in them being preyed upon. And when you already have a species that is threatened, that can be a big deal. As you move down the food web, there are a lot of minute animals in the ocean that are the foundation of the food web. And they're very hard to assess because they're so small. You have to make a very deliberate effort to collect them and come up with some indicator of whether or not they're damaged. So that also is another type of cryptic mortality. It can go on without anybody noticing it. And then there's the issue of the bottom-dwelling animals getting buried by settled oil that is falling to the seafloor. There's the photograph on the lower left, you may not be able to see, but the white bar is the frame of one of our water samplers. Back in May, we accidentally lowered it a little too far and it hit the bottom. This was about south of Panama City, about 40% of the way back towards St. Pete from the spill. So this is a long distance away from the spill. The sampler hit the bottom, we pulled it back up, and it had oil smeared along it. If you could see the photograph better, you'd see fingerprints from where we all grabbed some of it to smell it and feel, and it was definitely oil. But we didn't report that. There's a lot of cases of oil get dismissed as being background oil, natural oil from seeps. So I actually hadn't even shown this photograph to very, very many people. The photograph on the right is from a more formal expedition where David Hollander and his colleagues specifically looked for oil on the seafloor in August, and they found it. And then subsequent research at the University of Georgia determined that this speckled mass of oil can actually get to be very thick, several inches. And in that case, it's going